Hey everyone, it's Tara Bunny, a software engineer who codes for fun and not just for work. And I have a computer science degree, which sounds impressive until you realize that I didn't know how to build anything. I didn't realize it until my first job that everything I learned in school was theory and everything I needed at work was not that. In this video, I'm going to tell you the exact moment when I realized that theory is not the same as practice, and I'm also going to explain why, if you feel the same way, that doesn't mean you're broken, it just means you're learning something new. So computer science teaches you how to think about things algor- algor- algorithmically, like algorithms, data structures, and complexity analysis, how to prove your solutions actually work. And I'm not gonna lie, I loved it. I thought it was really fun stuff. The thing about CS though is that it's fundamentally about stripping all the irrelevant details. You strip a problem down to its absolute essence, you build abstractions, you disregard all the messy real world details, and honestly, that's the whole point. You're not thinking about what happens when somebody presses this button, or you're not thinking about what happens in 6 months when somebody needs to read this code and figure out what's going on. No, you just go straight into it, solving the problem. And that's computer science. And I'm not saying it's useless. I think it's absolutely necessary. I needed it. A lot of people need it. But I just think it's incomplete, because here's what computer science doesn't teach you. It doesn't teach you about real code. It doesn't teach you about code that has existed for years. It doesn't teach you about code that has been touched by 20 people in the past 5 years. It doesn't teach you about code that was written by somebody many years ago and you have to figure out their design details based on the commit messages. And it definitely doesn't teach you code that you have to figure out what's going on your own because there's no documentation anywhere. It teaches you to solve new problems, and it teaches you to build things from scratch where you were able to make every single decision. Working with real code teaches you something completely different. It teaches you how to navigate existing systems, it teaches you how to understand design decisions that you didn't make, and it teaches you how to make code changes without breaking everything. So school taught me how to solve problems in the abstract, but working in the real world requires a completely different set of skills. It's about navigating systems you didn't build, understanding code you didn't write, understanding how to make code changes without breaking everything. And I had zero training for that in school. Zero. Okay, so my first internship was at Microsoft on the Azure Kubernetes Service team, and I was so pumped. I did all the interview prep for that interview. I learned how to reverse the linked list in my sleep. I knew recursion. I knew complexity analysis. I knew all that stuff, and I was ready to go. They gave me my intern project, which was to implement an additional notification system, which sounds pretty easy and perfect, right? But I want you to really picture this. I had never worked with a code base that large. Since this was my first professional experience, I had never seen a code base that big with like thousands of files and so many microservices that I didn't even know existed, dependencies running into more dependencies, and just layering all up the dependency chain. It felt like walking into a library where all the books are in a language you kind of understand, but not really. And this is what really got me. My text editor, which was amazing, Goland, has this feature where you can highlight a function name, and when you click on it, it'll jump to the function definition. And I thought that was really cool, and I thought it would solve all my problems. But then what ended up happening is I would jump to a function definition and then find 3 more functions that I didn't know about. So I jumped to those definitions, and then it just kept going and going on. I ended up many layers into the function abyss, and I didn't know what any of them did. And when it came time to actually implementing my feature, I was like,
where do I even put this? How do I know I'm not going to mess everything up just by changing this one little thing with so many dependencies?
And you see, that wasn't a computer science problem. Like, using a better algorithm wasn't going to help me in that situation. That wasn't the issue. The problem was I didn't know how to understand a system. I didn't know how to read through and understand dependencies and be able to tell why some things were organized the way they were. And that's just something nobody teaches you. I didn't have a framework for it. I didn't have any classes for it. My degree definitely did not mention it. I think a lot of developers hit this wall and think something's wrong with them. Like, they studied for this, they passed the interviews, they know computer science, so why can't they do the job? You're not broken. You just learned one skill really well, and now you're learning a different skill. The stuff I learned in school is still totally necessary. I use it almost every day. It just isn't sufficient. So here's what I want you to know. If you have a CS degree or you studied a lot of theory, but then you hit this wall when you start working, I want you to know that it's not a sign that you're not cut out for this. That's not a personal failure. It's literally just a sign that theory is different from practice. You can study all the algorithms, you can ace every technical interview, but when it comes to reading existing code and figuring out why it was built that way, it does take practice. And you can't fully learn it in school because you need that practice to take place on real systems. What I wish someone had told me back at Microsoft is that I didn't need to understand the code base in my first week or even month. The fact that I felt lost wasn't because I was unprepared. It's because understanding a massive interconnected system built over many years is difficult. It's genuinely a hard problem. It takes time, and that's not something you can learn from a textbook. You learn it by making mistakes, by sitting with code that doesn't make sense to you, and then figuring out why it exists. So here's the thing. All the theory I learned, data structures, algorithms, and complexity analysis, they're foundational, and I do need them. But it's not enough on its own. You have to learn how to work in real systems, which takes practice, not reading. That's why I'm building this series the way I am. The Python tutorials coming up are not just about learning syntax, they're about teaching you how to think like someone working in the real world. Like, how do you make your code actually make sense? How do you structure your files and functions so that the next person, I don't know, in 6 months can figure out what you're doing? That's the practice foundation. That's where you start. And now, is this the full journey? No. The full journey includes reading massive code bases, understanding architectural decisions, navigating systems that don't make sense. But you can't do that unless you know how to write clean code first. And I'm not going to pretend that learning from tutorials is the same as working from a real code base, because it definitely isn't. You need practice on actual projects to develop that skill, but foundations still matter. Like if you can learn how to write clean code and organize code, then you can better understand some decisions that previous engineers have made before you and learn through even years of buried iteration. So the series is theory foundation plus practical examples, then practice on real code, which is the next part of the journey and something we'll keep talking about. If this resonated with you, consider subscribing to my channel. If you feel lost at work or you just got a computer science degree, this channel was literally made for you because I want to build together and be here for you for what's to come. Here's the final thing I want you to remember. If you learn theory in school and you hit a wall while you're at work, I want you to remember that you're not dumb, you are cut out for this, and you do work hard. You're in the middle of learning a new skill, and the only way through it is forward. Shout out to everyone who has subscribed since last week. I'll see you in the next video. Stay curious.